Before going on with this one, actually I was looking at the last video and I realized I didn't follow up on that release thing. This is the comment that, this is in this case to do with DirectX, but you'll see this elsewhere, I'm sure, as well. The return value for an interface, so from calling release on an interface, decreases reference count by 1. The return value is the new reference count. And then there's this. This value is for diagnostic and testing purposes only. So it's presumably they're saying it's not a reliable number. I'm not exactly sure why, but it's probably like I said. There's no requirement that release functions behave properly in this manner. You can't trust it. Okay. It's true that the release function might behave perfectly well, but maybe some people forget to return the value or something. Anyway, something else I wanted to add to the head of this video. Hello again, and welcome back to the I don't know what we call this, exploration of COM from another point of view. The point of view being not really using COM to do COM. Now what I'd like to do first on is fix this problem, even though we're not going to use it. We'll just take this, put that there, and we'll call a function do the command. We'll put this here. Then it doesn't matter how it returns. Those two will definitely get called. We'll clear that function up here. Or put main down below. Either way, we'll put main down below. So CoInitialize will get called and it will do the COM dance, and CoInitialize will be CoInitialize will be called. And we may not need those at all. Now, one thing I realized and recognized about this adding and subtracting 8 business, this comes back to a comment. Initially, when I was making those functions, I said you got to be careful. Don't call this an I unknown, or else you get the wrong offset, right? Or it'll change. It's not a trivial cast. Something goes up or down by an amount. Well, it turns out it's exactly the amount that we want it to go up and down. If I pass in here, I haven't changed this. This pointer, PCF, interpreted as an I unknown pointer, then this will, before I had, what was it now? added 8 bytes, right? 2 D words. Well, that was what I meant by the fact that this value changed from what I passed in. It had altered its numerically its value by 8. But if I just don't add that 8, then all I got to do is take star of the pointer that passed in, and I get the table, dynamic dispatch table. So I can use IUnknown star in that case. In the case where the thing actually is an IUnknown, like this, right, then it doesn't modify the pointer, and again it works, right, because it's already it's already at the right spot, so I don't need to add the 8 that I was subtracting off before. So I can use the same function in both cases and pass in either a regular pointer or an interface pointer, and the cast, this is a static cast, will adjust the pointer to be a COM style pointer, I suppose, which when dereferenced gives you its dispatch table. Okay, so now that means that I can use these same functions for both projects. What I did was I put into the COM header MISC support H, which has those two functions. So in this project I can use all those functions and print all the same things out. Dynamic dispatch table. Like that. Cool. This function. Okay. And that's it. If I want to print out this address. Query interface. I don't like this p-mine, we'll call it again. It's p math object or something. Oh, what's it called? We can name it. It has a name. We'll register it. Mine lib. How about math object? Lib corresponds to this thing, the class, okay? But the object, the interface that we're retrieving is a math object. So let's call this, let's change it to pmath. Looks better. I think it looks better. Okay. Okay. Right. It's true. 0 would indicate success. Now for cubing numbers, we don't actually have a... This should return some fail value for instance. Let's see, what's the biggest number we can cube as a long? We can go to 2 to the 31-ish. A third of that is 2 to the 10, which is 1024. 2000 is too much. Oh, dear. Yeah, see that? The cube came back negative. What is it? Int long max is 2 to the 31. Is it? So the maximum 2 to the 10 is 1024. If we did 1,150, that works. We can go to nearly double, I think, or halfway between that 1024 and two. 1536. Doesn't work. Doesn't work. So we can't go to half. Maybe a third. 1365. No, it's closer, but it's nearly there. It's not very much. Well, it's 13 here. No. What is the cube root of long max? That's long max. Real calculator. Bracket. 1290. So we should be able to do 12, and that's more, slightly more than that. 1290 should fail. 1289, I think is the max. Not that it matters. But that could come back as a double. I mean, as a, well, a Q word, or in the floating point. 1290 should fail. Didn't. 1291. fails. Let's see. So 12.9 is the max Q. Not important. Now what I want to do is I want to do this manually. I want to get I want to implement this function. I'm going to call it my CoCreateInstance. Leave everything the same. No, it's going to take, this is called a ref IID, I think. That's the class identifier. No, it shouldn't be taking a long time. Actually, I said this is the one, but really the one I want is platform SDK. It's pretty much the same. Okay, unknown. So that. Context. I don't know what. I read somewhere there was only one value for this, but then I saw a whole bunch of other values. Now this would be the interface we're looking for in the class, and this is where the result goes. Okay. Now looking at how this registrar thing works. To register the object, now we're going to have, well, no, we can read, I think, from, I hope we can read from, we must be able to, this thing works. Oh, not necessarily. It's going to com. Let's see now, class ID. Class ID 20. Oh, hang on, I'll find it. Okay, just an update here on my progress. Turns out, even not being an administrator, I can still read values from HKey local machine, and this is the key where the DLL name is, or path is held. And I read the key, and I read the value there. I made up this same function here. So this is the key, the subkeys that we're looking for. The root key local machine. Open the key, succeeds. and it's calling query value. It has no name. It's just the one that falls in the default, so that's unnamed, and that returns the address of the DLL. So that's succeed. Did close the key. Now I'm loading that library. As you can see, it loads to its normal address, 10,000 or 10 whatever, 470. I'm printing out as we go along here. So I've loaded this library, and now I want to find the magic function DLL get class object, which it locates at 10010F5. And there it is. All these are, of course, jumps. So you call this, and that takes you to get class object. And that's what I want to do next, is call that function. So that's my progress report so far. Okay, update time. Now what I wanted to do here is essentially what I've got done without the final bit. Here's main, okay, and I do the condense, this function I added, which is really main. Now actually let's call this main, because there's nothing here. I'd had CoInitialize and uninitialize surrounding this part, but I'm no longer initializing or uninitializing com, so there's no com. Com doesn't exist, at least as far as CoInitialize or anything is concerned. The only thing that worried me a little was this function, which I don't know why it doesn't show up. It's in the header, in this header file. Okay, now it used to be somewhere else. That's probably the problem. I'll just get rid of that. Right. Now previously that was in this file at the bottom. And everything's going crazy with me, hopefully. Okay. Now this is using a function provided by com, anyway, some part of com anyway, that has to do with OLE string. It converts it. It's a string conversion, from our ref ID, which is just a GUID, into what they call an OLE string, which is a wide character string. And then there's this co-task mem free, so it allocates memory somewhere in the CO area, which I'm avoiding. So I just, instead of using that, I just figured it's an easy enough function to write. So I just wrote it. It doesn't require any wide character strings. Just take this, cast it as a GUID, which is a regular old struct, right? And it's broken up. The resulting string has 5 parts, separated with dashes and with curly braces. So I can extract those parts and then print them out. So there's no co anything in there. So there's no co there, and there's no co anywhere else that I can see. So now I'm calling from main my CoCreateInstance, class ID, inproc server, and unknown as the type of object I want back to be stored here, just as before. Let's have the word my in front. Here's the implementation. I'm trying to do what I think COM is doing. So first I convert that to a regular, I convert the class ID to a string using my magic function. And now I'm just asserting basically that the only valid context is improc server. If that's the case, then the place to locate the DLL, well, I know just by seeing where it was set up, is in HQ local machine, software classes, CLS ID, and then this weirdo string, improc server 32, as you saw before, and I find the DLL. Okay, so I have a string now, the result, which will be a path name of DLL. And then I'm going to do load library, and now I'm locating the function called getClassObject, which I know should be in the library. So get proc address, and that's the procedure I'm looking for. Alright, print it out where it is. Now I want to create an I-class factory. That's one of these things. And so that's what that function is designed to do. Well, it's designed to get you a class object. First parameter is the identifier for the main class. Whatever the thing that identifies the DLL and the object and everything. And the interface that I want is the class factory interface, and I pass in this pointer here as a void ***. That's what you're supposed to do. And now I'm doing what I think OLE32 is doing: add ref and release, and then asserting that the number of refs is equal to 1. Okay. Now what I want to do is create, actually this should be HR, create instance unc outer, which I should be asserting is null. It should be null. It gets asserted, I swear. The ID that was passed into this function, second, fourth parameter, and the pointer to object that was passed in, the last argument. Okay. Now I'm releasing the factory, which I think is what we've seen. That's what happens. The factory creates exactly one instance of whatever we were asked for, whatever was asked for. Whether it succeeds or not, we then release the factory object as it's no longer needed and return the result. Okay. that should leave us on this line. Now the rest here, I'm using COM as though we're just regular old COM, even though COM itself has not been initialized and no CoCreateInstance or anything has been called through the mechanism of COM. I'm treating this as if I have. And as you'll see, compiled, it should work. It did work a moment ago, so it works again. Now, as far as making these function calls properly, that's just another thing to work out. It should be nothing. So I'll run up to here. So here we are in main. Okay, now I'm calling my own function. No CoInitialize or anything you can call. Now I'm using this my own function so that we don't have to rely on the company. And this is, I'll just go through it once, building that string, 6 more bytes, tie them together, and that's the right number, it turns out. Okay, now this is the only context that we import. Here I'm creating a subkey string. Here, that's the one that should contain the pointer to the path to the DLL. The root is local machine, and I want to find this key, this subkey. And it's succeeded, so I have an H key to see, it turns out. Now I want to read in the value whose name is nothing, the default value. That's this one. And it worked. There's a DLL. Okay. Close the key, because we're done with it. Now I do load library of the result. Here, DLL main was called. When you load library of DLL, this DLL main gets called naturally with process attached. And so that succeeded. I'm printing out the library where it got loaded, usual spot. And now attempting to find that function. Get class object, which succeeds. And I print it out. It happens to be at this address. Now I want to get and pass in class identifier, the interface I want, and where I want the result stored. Now I can just step over this. I'm going to just step over it and show you that this is exactly like before. This is what happened. All the same comments as before. All the same things happened as before. I printed the number of functions supported. We did a query interface for a factory. And we incremented a reference count. And the result is SOK. Now I'm just doing that thing that I think it does, adding a ref, subtracting a ref, and making sure that this value is 1. Now I'm doing a create instance of what I asked for was an I unknown. Now again, I can step into it, but I'm going to step over it. And I'll show you what happened. Create instance of 46, which is I unknown. That causes a new instance of my interface to be created. And we add ref to that thing, whatever it is. Now I'm releasing the factory, we're done with it. I'm returning H result. It didn't fail. Now, as far as reference counts go, the pointer to the class factory was deleted as before, and we have a single reference count to something, to an I unknown. Now we want to extract from the unknown interface pointer given my interface, which is the math object, and store it here. The result is OK, so I can release the unknown interface exactly as before, and everything's happening exactly as before. I'm going to enter a number in, and printing the same things as before. Support 6 functions. The dynamic dispatch is here. Its query interface is there, and so on and so forth. Now I'm going to step into this just to show you that it goes through. It's going into the DLL, and it's calling the functions. Now this is a COM call, right? But COM hasn't been initialized yet, right? Or anything. But we're using it. I'm using this as if I was using regular old COM. And it's working. We're cubed. We get square root, right? We'll release the object. Gets deleted. And we're done. Now, the only thing now left to do, which you can imagine, is not pretty much nothing, is to, instead of using these arrows, just do a regular function call. But really, there's not anything, that's just a matter of fun, right? What we have here is a COM server working exactly as it normally would, where COM itself hasn't been used. That is, OLE32.DLL was never loaded. Now how can I prove that that's true? Well, if I run up to here, it may have got loaded for some other reason. It is loaded here for something. Master. But it's not being used. If I put breakpoints like I had before on the add ref, there's no OLE32. Before it was going into NTDLL and OLE32 and coming back out. Again, no OLE, nothing. Again, same. There's nothing to do. There's nothing in this project to do with COM, turns out. And yet we're using COM. So we can see that the syntax and everything of COM is something that just comes out of the header files. But you can certainly use it without the use of OLE32 for this type of COM object anyway. It's simple type by just load library, get proc address, and of course I haven't yet done this part by just walking through the dynamic dispatch table, but you saw that I found those tables, so it should be an easy step to complete this main such that I can do the lookup manually for these functions. I have to figure out what comes first, add ref or release. I think it goes query interface. Well, it says in the header file. So add ref, then release. So query, add ref, release, and then the order of functions is exactly as they are listed following that for everything. So I guess I'll upload this as it is, and maybe I'll just fiddle around and finish this last bit on my own, and I can just show you quickly on the next one. I'll invent my own arrow, or I turn this into a function call. Okay, that's about it there. As you can see, there's really very little to it.